Pretty much everything you do online, whether you're streaming a movie or just saving a file, it all leans on one single, really powerful idea. It's a technology called virtualization, and it's basically the art of making one computer act like a whole bunch of them. So let's break down how it all works. So it really all boils down to this one question. How is it possible for one single server, one physical box, to do the work of 10 or even 100 separate machines? The answer isn't some kind of magic. It's just a really brilliant piece of software engineering that completely changed how we think about computing. And this visual, it says it all. On the left, you've got the old way of doing things. One server, one job. Super simple, sure, but also incredibly inefficient. Then on the right, you see the revolution. One single server running lots of completely separate virtual computers right inside it. This is the core idea we're going to unpack. All right, so how do we make that leap from the old way to the new way? To get it, we need to break down the fundamentals, what this technology actually is and why it became so absolutely essential. So at its core, virtualization is really just a way to run multiple isolated virtual computers, we call them VMs, on a single piece of physical hardware. Now, each one of these VMs acts just like a real computer. It's got its own operating system, its own apps, its own settings. But here's the key. They aren't real hardware. They're defined completely by software. So why did we even need to do this? Well, this chart right here shows you the problem perfectly. Before virtualization came along, a typical server might only be using, 15% of its total power at any given time. That means a staggering 85% of that expensive hardware, all that power, all that cooling, was just sitting there, doing nothing, completely wasted. Virtualization was born from the need to get that waste back. And when you start reclaiming all that waste, you get some huge wins. 5 big ones, really. First off, resource efficiency. You're finally using your hardware to its full potential. Second, isolation. This is critical. If one virtual machine crashes, the others just keep on chugging along, completely unaffected. Third, you get flexibility. You want to run Windows and Linux right next to each other on the same box? No problem. Fourth, management becomes a dream. You can back up or move entire machines in minutes. And finally, the big one, massive cost savings on hardware, power, and space. So how does this actually work under the hood? Well, for that, we need to pull back the curtain and meet the secret ingredient that makes it all possible, the hypervisor. The hypervisor is basically the brains of the whole operation. It's the special layer of software that sits right between the physical hardware and all those virtual machines. The best way to think of it is as the ultimate traffic cop. It's what creates the VMs, it's what runs them, and it manages the flow of all the resources, the CPU power, the memory, the storage, making sure every VM gets what it needs without bumping into its neighbors. Now, there are 2 main flavors of hypervisor. On one hand, you have what's called a Type 1 or bare metal hypervisor. This is the super high-performance version that runs directly on the server's hardware. It's what powers pretty much every data center and cloud out there. On the other hand, you've got the Type 2 or hosted hypervisor. This one runs just like a regular app on top of your existing operating system, like Windows or Mac OS. It's perfect for developers, or really anyone who wants to run, say, Linux on their Windows PC. Okay, so we have our manager, the hypervisor, in place. Now let's see how you actually build one of these virtual machines layer by layer. It's actually a pretty simple but really powerful stack. At the very bottom, you've got the foundation, the physical hardware, the real CPU, the real RAM, the real disk drives. Sitting right on top of that is the hypervisor, our manager. And then, the hypervisor lets you build and run all of your virtual machines on top of it, and these are the software computers that do all the actual work. So let's peek inside one of these VMs. To the operating system running inside, everything looks totally normal. It thinks it has its own dedicated hardware, a virtual CPU, virtual memory, a virtual network card. But here's the really wild part. That virtual disk, it's not a physical drive at all. It's just one big file sitting on the main server's storage. So let's get a little more specific. How does the hypervisor actually juggle all this stuff? Well, for the CPU, it intelligently schedules all the little tasks from all the different VMs onto the physical processor cores, and it often uses special hardware features to make it run super fast. For memory, it maps the virtual RAM from each machine to a little slice of the physical RAM, and this is important, it keeps them totally isolated and secure from each other. And for storage? Well, by pretending a hard disk is just a simple file, it unlocks some incredible features, which we're about to see. And now we get to the really cool part. Because these machines are just software, we can do things with them that were, well, just impossible with physical hardware. Let's take a look at these virtual machine superpowers. First up, we have snapshots. This is, and I'm not exaggerating, an undo button for an entire computer. Let's say you're about to install a risky update. Right before you do, you take a snapshot. If anything goes wrong, and I mean anything, you just click a button and roll the entire machine right back to that exact moment. It's a lifesaver. Next up, there's cloning. This is exactly what it sounds like. It's copy and paste, but for an entire server. Let's say you need 10 identical web servers. You don't build 10 from scratch. You build one, get it absolutely perfect, and then you just clone it 9 times. It's an unbelievably fast and efficient way to scale up your applications. Okay, this one might be my favorite. Live migration. Think of it as a teleporter. You can take a virtual machine that is actively running, serving users, and move it from one physical server to a completely different one with absolutely zero downtime. Your users never even notice. It's how data centers can do hardware maintenance without ever having to take services offline. It's just incredible. So, you take all these amazing features, the efficiency, the flexibility, these superpowers like cloning and live migration, and you put them all together. They weren't just neat tricks. They were the building blocks for one of the biggest technological shifts ever. This is what paved the way for the cloud as we know it today. And this quote right here just nails it. It's simple, right? Fewer physical servers means less money spent on everything: hardware, electricity, cooling, real estate. The massive cost savings and the crazy operational efficiencies from virtualization, that was the economic engine that made cloud computing possible. Companies could pack an unbelievable amount of computing power into their data centers for a fraction of the old cost, and then rent it out to the rest of us. So here's the bottom line. We've virtualized servers to build the cloud, but the idea was too good to stop there. The exact same principles are now transforming everything from computer networks to storage systems and even our own desktop computers. Which leaves us with a really fascinating final thought. It makes you wonder, right? What happens next when this powerful idea of separating the hardware from the software gets applied, well, everywhere?